I'm working on my cover crop seeder today, trying to get rate control on that I can run through the AgLeader display using an InCommand 1200. And it has a hydraulic drive on the cover crop airbox already, but it did not have a high quality rate encoder. It only had 3 pulses per revolution. So I've got this from AgLeader. This is their rate encoder, and it is rated at 600 pulses per revolution. So we're going to get a lot more resolution out of that per revolution. We're going to know very accurately how fast that shaft is turning, and that's going to allow me to get very good rate control. So you can see it's got a round hole in it. I got the insert. It needs to go over a hex shaft. I got the insert that fits 7/8. Well, we put the insert in. We put that over a 3/4 inch hex shaft, and it's just a little bit loose. So I'm going to go ahead and 3D print a hex shaft insert for this and be able to put this together. So I've got a digital micrometer here. I'm going to just go ahead and take some measurements quick. The inside diameter here is 1.12. We've got a depth of 1.56. So I'm going to take those measurements and just jump over here and build that. Now I'm just using 3D Builder. This is on any Windows 10 or newer PC. I am running Windows 11 here, but we're going to make a new scene. We're going to come in here and just insert an object. So I'm going to start with a cylinder. Now we're going to resize it. We know that we've got an inside diameter on that rate encoder of 1.12. So I'm going to just type that in. And I need to do my X the same way. All right, so we've got the correct diameter to fit in there. Now we need to get the correct height. And that was 1.56. All right, all we've got to do here from here is make a hex hole down through the middle of that. So we can come up here and grab a hexagon. Now, what I'm going to do here is I'm actually going to block the dimensions, and I'll show you why. My X and Y axis, so X is measuring point to point on that hexagon. Y is measuring flat side to flat side. I need that to be 3/4 inch flat side to fit that 3/4 inch hex shaft. So with the dimensions locked, I don't have to worry about what the X measurement is going to be. I size the Y measurement at 3/4, and it's going to automatically size that to 0.86. Now, I mentioned the other insert I had is at, I got it as a 7/8 insert, which 7 divided by 8 gives us 0.875. So that 0.86, my insert's just a little bit too big to be able to fit real well on there. And it's not allowing it to bite enough that I can make that go on the hex shaft. And I thought, you know, this is just going to be pretty easy to make this go. All right, now my hex is actually inside of the sphere, or the cylinder rather, sorry. So what I'm going to do, I'm going to unlock the measurements, and I'm just going to put some height on that so that we can get it out of there. We'll make it 2 inches. Okay, and then I'm going to slide that up. So you can see it sticking out top and bottom. We're centered. We've got our 3/4 inch hex shaft in there. So now we're just going to go in here and hit subtract. Now we've got a 3/4 inch hex hole down through the middle of that sphere. That's everything I need to be able to send that file over to my 3D printer. So we'll go ahead and get it over on the 3D printer here in just a minute. That in. And what I'm going to do is I'm just going to take that and I'm going to drag it over here and drop it into Cura. Now, Cura is a slicer software. This is what talks to the 3D printer. So once we have the files made in here, we can take and just drag that in. I can rotate that around. You can see it's hex shaft in the middle. It's round on the outside. We can look at it from the bottom. The hex goes all the way through. And then we come in here and we get some things set the way we want them. So we tell it what thickness of walls we want, all those types of things, what kind of infill. Instead of a 20% infill, I want to make this pretty solid, so I'm going to make it 100% infill. Lots of other settings in here, nothing real earth-shattering. We don't really need to worry about support build plate adhesion. We're gonna do a skirt. In other words, we're gonna make a line around the outside of it first, just to make sure everything sticks. And there should be enough material there that that's going to stick down pretty well. It's good enough sized. So from there, we just hit slice. It slices that. It's going to take 2 hours and 22 minutes to print. It's going to cost me about 40 cents worth of material. And I use a program called Octoprint. I've got a little Raspberry Pi computer controller hooked to my 3D printer. So instead of having to load things across on a micro SD card, I can just hit print with Octoprint. This sends it right over to there. We've got it saved into Octoprint as G code. That's the code that the computer can understand. So in Octoprint, then we can come in here and we can look for that file. So we've got that right here. We're going to select that file. And we're just going to hit print. So that's going to start. You see my bar graph here changed. That's actually heating up the bed of the 3D printer. Once it gets the bed to the desired temperature, then it'll heat up the hot end or the nozzle. And we get that up to temp, and it'll start its print. We're going to actually record that or save that with a time lapse. I've got a camera hooked up to it, so it'll automatically save that. But that gives us a pretty good way to see what's going on. I'll pop back in and show you what the finished product looks like. Okay, I've got the 3D printer heated up, the file loaded, and we're looking at a video of the BL Touch doing a bed leveling. So you can see that little sensor changing colors, and it extends down a little piece of plastic there, comes down, touches the bed, and knows right where it is so that it can maintain correct height when it goes to the print. It's going to go through and touch the bed in several different spots to be able to make that work. Okay, we got the 3D printer up and rolling. I'll let you guys just watch this for a minute. Okay, so we got the 3D print done. Took 2 hours and 20 minutes. You can see my hot end temp, my nozzle temp, and my bed temp have both been commanded to come back down, so they're starting to drop off. We're rendering a time lapse of that, so I'll post that in here as well. You can see the part over there, so I'm gonna go ahead and grab that off the printer. Here it is. So we've got that nice hex there. We hold that up next to the factory one that that we were trying to mimic. Matches right up. Slides right into the rate encoder. So next up is to go put it on the cover crop seeder. It's the moment of truth. Here is the cover crop seeder. Let's first look at what we're working with. So the existing sensor here just has these little magnets, and it's just a shaft speed sensor. So we're going to take that apart, and we're going to replace all of that. We'll move this sensor back out of the way, because we're going to put that sensor there in. Now, I did do a little redesign on the piece that we 3D printed. I put a groove in it, like that factory collar had, or that insert, because I want to be able to have that tightened down around the shaft when I get it over that shaft.
You can see it fits in there real nice, but now I've got the ability for that to pinch down and to hold in there a little bit better. So all that's left now is put it all together, and we'll be out and running in no time flat. That's going to make a really nice setup, and we'll be out in the field and have full control with the InCommand. We got everything hooked up, tied up, ready to go. I've been out in the field, got about 10 acres done out here now, running the cover crop seeder. You can see I've got my rate set at 50 pounds an acre. That's exactly what I'm putting on. My shaft speed is staying real steady. I'm slowed down a little bit here because it's rough otherwise, so bouncing along through the field. But I've got auto steer on that same display. You can see the seeder back there, and it's doing its thing. When we did our initial calibration, I dispensed some seed into a bucket and then went and weighed it, and we were awful close. So I got that dialed in, and I think I'm going to be real close now that we're out in the field with the initial calibration on this. So successful project put together, up and rolling and working.